We're going to finish up the brain unit with our last lecture here. We're going to pick up where we left off with the reticular formation. So in that last lecture video, I talked about this region of the brainstem that is really, it takes up multiple areas of the brainstem. It's found in the midbrain, the pons, and the medulla. But the reticular formation has a very important job. It wakes up your cerebrum. It wakes you up so you're conscious and aware of what's going on around you. And when it's not activated, it puts you into a sleep state, essentially. So if you take a look here, what this says is the reticular formation, basically it filters incoming information. Sound, sight, smell, those kind of things. And it determines whether or not you need to be awake. So if you're in the middle of sleeping, and there's a fire, you might wake up because you might smell that fire, and that's going to cause your reticular formation to register danger, wake up your cerebrum, and then boom, you wake up and you're ready to go. Better example is an alarm, right? So when your alarm goes off, there's that noise is very jarring, and the reason why you use that tone is so it pulls you out of that sleep. So this is a sound that wasn't there before, and now all of a sudden it's there, and your brain sees it as a threat, so it wakes you up and you're ready to go. Now, some people can sleep through an alarm, and does that mean that you are higher evolved? I don't know. It means that you might sleep through being attacked, so I don't think that's higher evolved. But everyone's reticular formation is different. Some are more sensitive than others, and they'll wake. So some people that are heavy sleepers, their reticular formation takes a little more to get activated. And somebody who's a very light sleeper, it's the opposite. And you've all experienced it before, like I said. In class, if it gets, if the teacher's talking in a very monotone, blah, 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 and it's dark in the room, good luck staying awake, right? And that's because that reticular formation is what triggers you to wake up. And if it gets destroyed entirely, that leads to a coma state. And, if it's completely destroyed, a person will never come out of the coma. That's how a doctor can say, you might be wondering, you see these shows, like how does a doctor know whether or not this person has a chance of coming out of the coma? It depends on how badly damaged that part of their brain is. But we're going to talk about sleep today. And sleep is an area of brain research that we still don't have a clue. We really don't. We know it's important. We know we need it, right? So how much sleep do you need? Well, everyone's a little bit different, but the average adult human needs between 7 to 8 hours. That's what they say. High school students, teenagers need between 9 to 11 hours of sleep. That's because your brain is literally still forming, and you need to sleep to have that happen. And I got to say, I'm always concerned about the amount of sleep students get. It's less and less. I understand it. If I had a cell phone with everything I'd ever want in the world, at my fingertips, I would probably have a hard time falling asleep too. But it's very important. So we're going to focus on a little bit about what we do know about sleep. And then I'm going to show you some videos to hopefully go further in depth on it. What we do know is that there's actually two types of sleep that occurs. And they're called slow wave and fast wave or high wave, better known as REM or non-REM. And we'll talk more about that in a moment. What does REM stand for? But slow wave sleep, so there's waves, brain waves, and there's different types of waves. When you're active, you're going to get like alpha waves, and there's beta waves, there's gamma waves, and that has to do with brain activity. So when you're meditating, your brain waves are going to be very different than if you were, let's say, playing a sport or doing something active or talking. So when you're sleeping, you're going to be in this slow wave sleep, and your heart rate is going to be decreased. Your blood pressure is going to go down. It's restful, not restless. It's restful sleep, and it takes about 70-90 minutes of time. So we sleep in cycles, and I'll talk more about that in a moment. Now, there's a couple things that I have written here that really we don't think are true anymore. One thing that we used to think is when you're in the slow wave or non-REM sleep that you don't dream. Well, what they're finding now is you can dream at any point of sleep. So you could be dreaming in this REM phase, which I'm going to talk about in a minute, but you could also dream in this state. And I'm going to talk more about dreams in a moment, but we really don't have a clue as to what dreams are. If they have meaning at all, is it just nonsense? Is there some underlying meaning that you can interpret? We really don't know. But what happens is, what we do know is that we have this sleep cycle where every 90 minutes or so, you have another cycle. And the first 70 to 90 minutes of that cycle are going to be this slow wave, what we call non-REM or non-random eye movement. And this is that restful sleep that you really need to recharge. The second type of sleep, or the second part of this cycle, is called REM sleep, or rapid eye movement. And it's named that because eyes move side to side. So you might know people who sleep with their eyes open. It's weird. It's a very strange thing to see. But you can see, sometimes you'll see their eyes start moving around. And you can see someone's eyes moving under their eyelids as well. That is called paradoxical sleep or dream sleep. That is when you do most of your dreaming. Now, here's the thing that's really bizarre. It only lasts about 5 to 15 minutes. So when you have a dream that feels like it's hours long, chances are it was only a few minutes long. And we do know, like I said, that you do dream in that other stage, but most of the dreaming happens in the last 5 to 15 minutes of the cycle. At this point, your heart rate goes up. Your breathing rate changes. You're reacting to your dream. They've done a lot of studies on this where, like, for example, if I'm looking to the right in my dream, my eyes are going to look to the right. And they can actually interpret a lot of what's happening in a person's dream by their eye movements. But what we do know is you need a certain number of these cycles. So let's say you sleep for 8 hours. Well, that's going to be 4 cycles, right? If they're an hour and a half each. That's why if you wake up naturally, let's say I wake up at like 5 in the morning and my alarm's set for 5:30. I woke up on my own. Chances are I was at the end of one of those cycles. If I go back to sleep again and then get woken up by my alarm, you've probably had this happen before. You feel exhausted, like you should have just woken up a half hour ago. And that's because you woke up in the middle of one of those cycles. So you need to have a certain number of cycles throughout the night to get a good sleep. But sometimes you're better off sleeping 3 hours than you are sleeping 4 because you've gone through 2 cycles with the 3, and with the 4th, you're getting pushed into that next level. But we'll talk a little more about sleep in class, and we'll watch a video on it. But what we do know is that this part of sleep, this REM sleep, is so important that when you don't get it, the next night you're going to actually make up for it. You're going to have more REM sleep. And they've done studies where they'll have someone not sleep, and then the next night the amount of REM sleep they have goes up. So it's really interesting, and we'll talk more about this in class. But let's finish up with the section with the last part of the brain, which is the cerebellum. And the cerebellum's interesting because it looks like its own little separate brain. It looks like a mini brain hanging off the back, and we'll talk about what's going on there. What it is, it's mostly white matter. So if you look at it, it's got this tree-like pattern in there made up of white matter. And white matter means that it has axons. So the gray matter is on the outside, and that's going to be those cell bodies, and the white matter are going to be the axons. And there's a name for this little structure in there. It's called arbor vitae, which means tree of life. Arbor means tree, vitae means life. So this is just a structure in there that you should be familiar with. The arbor vitae is what is in the cerebellum. So what is the cerebellum? Why do we have it, and why do all animals have the cerebellum? Because remember, this is part of that reptile brain. Well, this is the part of the brain that really allows you to communicate with your environment in terms of your movements. So right now, everybody's sitting upright. How do you know you're sitting upright? Well, if you close your eyes, do you still know that you're upright? Yeah, if I close my eyes right now, I know my head's up here and my feet are down there. Well, the reason why I know that is because my cerebellum is keeping track of all these things. The cerebellum is what allows you to keep your balance. So if you stand up and stand on one foot, if you can do that right now, your cerebellum is what's allowing you to balance your weight so that gravity's pulling down and you don't fall over. So basically, it takes information about your body position, where you are in terms of, how far away are you from the wall. Like, for example, I have a water bottle right here. If I put it down and pick it up, why didn't I do that? The reason I didn't do that is because I knew how far away it was, and I knew when to relax and put it down. So all those things, like how do I know to reach for someone, slapping someone high five, it's being able to integrate where you are with your surroundings to make the movements make sense. So it's really an important part of the brain in terms of coordinated movements. It also stores coordinated movements. So I've used this example before. Like if you learn how to throw a baseball or shoot a basketball or, pole vault or any sport, you do that once or twice, and maybe more than once or twice. You do that many times, and you start to store those patterns in the cerebellum. And then at a certain point, you don't have to think about it again. A better example is like tying your shoes. If I tell you to explain to me how to tie your shoes, you're probably not going to be able to do it. You're going to be like, but if I say tie your shoes right now, boom, you do it without even thinking. You could talk to somebody while you're tying your shoes. That's because it's stored in your cerebellum. So your cerebellum is really important for maintaining equilibrium, sitting upright, your posture, because it's keeping track of everything around you and all your muscles are firing correctly to make that happen. And it also stores very coordinated, complex muscle function. And the way it does that is the motor cortex is up here. And I talked about this when we mentioned the pons. If I want to, let's say, learn how to throw a baseball, right? That is going to send information to my muscles in a specific way. And what happens is, as that information travels down from my motor cortex, down my spinal cord, when it hits the pons, a copy of that information gets sent to the cerebellum. And it stores it in that area, so that way the next time you do that, it has all that information right there. So you don't have to sit there and relearn how to shoot a free throw every time you do it. You just have to calm down and shoot your shot. If you have good body mechanics, you should be able to repeat that. That's where practice comes in. Practice is important for any movement because it allows you to store it and then have it accessible to you. So that's a really quick overview of the brain and what each part does. Obviously, there's a lot more to it than what I explained to you, but this is a nice little overview, and hopefully you have a good understanding now of how all your different brain components work together to make you function and get through this crazy thing called life. Thank you very much.